MCATs. This is 1.10 mathematical models and variation, and we're going to spend most of our time talking about variation. I do want you to have this definition in your notes, so I'm going to let you pause and write this information down. I also want you to look at the examples on this example 2 on page 104 about the sum of square differences, or the least squares regression line. So take a look at that. Please look down your book and make some notes in this area of your notes, and I'm going to take a look at that on Monday. Now, there are two types of linear models. One type is where your y-intercept is non-zero, and one type is when your y-intercept is 0. I want you to draw a picture of each, and maybe also give me an equation of each. I will look for that in your notes on Monday. Okay, here's where we're beginning to work some together. We want to talk about variation. There are three types of variation. There's direct variation, there is inverse variation, and there is joint variation. And then there's combinations of those things and variations. That's funny to say, variations of the variations, but there are differences in those types of variation. Let's first talk about direct variation. Direct variation is when the y-intercept is 0 and is said to vary directly with x. So notice that direct variation, the y varies directly as x, and y is directly proportional to x mean the same thing. And your little formula that you're going to focus on is this: y equals kx. And k is like a constant. In a linear equation, that would be like your slope, because your slope is a constant. Let's look at this example. In Pennsylvania, the state income tax is directly, there's our important part, and as soon as you see that, you're going to think of that equation, y equals kx, proportional to gross income. Also, the first thing that is stated in the problem is, I would say 99.9% of the time, your y value. It's the thing that comes first. So our income tax would be our y. So I'm going to call that, that's your state income tax versus your gross income tax. We'll call that G. So our state income tax times our gross income tax. So that's how I'm going to fill into that formula. I'm just substituting in the variables that would be represented in the problem. You're working in Pennsylvania and your state income tax deduction is $46.05 for a gross monthly income of $1,500. Find a mathematical model that gives the Pennsylvania state income tax in terms of gross income. Well, we already have that written out, state in terms of gross. So the state is equal in terms of gross. Let's figure out what we're missing. We know that the actual deduction, our state income tax deduction, is $46.05. What we don't is what percent that deduction is of our gross, and our gross salary is $1,500. So we're going to solve for k. I'm going to let you do that on your own. You can do that. When we solve for k, we're going to get that k is equal to approximately 0.0307. So that's about 3%, 3.07% of the gross income is our income tax that we have to pay. So in other words, if you make $1,500, then about 3.07% of it is going to go back to the state for their income tax. So let's write the equation out. Now I want to say S, the state income tax in terms of G, would be 0.0307, and we're just going to say G for the gross sales. So this would be the equation that we're looking at. So in other words, you could use this equation for any gross income that you had to find out what your sales tax was. All right, pause, take a look at that, make sure you understand it, and then we'll go on. This next example is very, very similar, except that we use it as an nth power. The variation varies as an nth power. Again, like I said, this is still direct variation, so the equation is still very similar. It's just that there is a power now assigned to your x value. That's the only difference. So I'm going to actually let you work through this problem. I want it to be the same thing. You're going to find the value of k, and then you're going to substitute it back in. Your final equation should be written as distance over time, and you should be able to give me the information for that formula, how that would be written. I want you to circle or highlight this. You can circle it in a highlighter or actually highlight over it, and this is the one thing one of the things I'm going to look for in your notes when I come by on Monday. So I want you to do this one on your own. So you can pause, and I'll be right here waiting for you. Next, we're going to talk about inverse variation. Sometimes I think of that as being inverted. That kind of helps me. That's the one where the x is now underneath the constant. It's kind of been inverted. I don't know. That's not mathematical. That just may be a way to help you remember it. So inverse variation is the following statements are true. It can be read as it varies inversely as x, or y is inversely proportional to x. Okay, those are both mean the same things. And here's the formula our little equation you're going to focus on is the y equals k over x. K over x. So k again is our constant. Let's take a look at this example and see if we can set this up. Remember, the first thing that comes up in the problem is most likely the y value. So it says a gas law states that the volume of an enclosed gas varies directly as the temperature and inversely as the pressure. Ooh, we're going to have several things here. So this is not just one thing. So we have direct, which we already know was the multiplication one, and we have inverse, which we know is division. So direct, something gets multiplied by the constant. Inverse, the constant is divided by that amount for the inverse value. So volume is what we're talking about. So that's going to represent our y. So volume equals, we know we're going to be dealing with a constant, and because we have both direct and inverse, I'm going to put a fraction bar that's multiplied at the top, divided at the bottom. So it says that an enclosed gas, that the volume of an enclosed gas varies directly. So the gas varies directly. That would mean multiplication. Varies directly as the temperature. So the temperature is going to be multiplied, the temperature of the gas. And the gas varies inversely as the pressure. So the pressure is going to be underneath. So the first thing is just setting this up correctly. Then we're just into substituting things in and finding our information. It wants us to, it says the pressure of gas is 0.75 centimeters, and when the temperature is 294, the volume is 8,000. So let's figure that out. So the volume is 8,000. We're looking for the constant. When the temperature is temperature is 294 Kelvin. And the pressure is 0.75. When you do that and you actually solve for K, you're going to get K is approximately, well actually I'm going to give you an exact answer. It's 1,000 over 49. 1,000 over 49. In this particular case, we would give you a calculator if we wanted that, or you could just have left it that K was equal to 8,000 times 0.75 divided by 294. So we could have said K is equal to 8,000 times 0.75 over 294. Okay, so you could have used all of that as your constant if I didn't give you a calculator. All right, next we're going to find the pressure when the temperature is 300 and the volume is 7,000. Okay, well let's first write our equation. We have the constant. I'm going to use this version of it. So we really have volume is the constant 1,000 over 49 times the temperature divided by the pressure. So now we have a base formula that we can use, and so we're going to find the pressure when the temperature is 300. So when our temperature, we're looking for the pressure this time. We might go ahead and rearrange our equation since we want to solve for P. So we would cross multiply and you would get VP equals 1,000 over 49T. And if you want to solve for pressure, you would divide all that by volume. That would give you your pressure. Now you can just substitute into this formula. Rearranging equations before you make the substitution is really important, especially in a physics class, so this might be very helpful for you. So the pressure that we're looking for is the 1,000 divided by 49, that constant, times the temperature of 300, all divided by 700, the volume of 7,000. Okay. And we would put that in the calculator. When we do, we would get approximately 0.87 kilometers per centimeter squared. All right, per square centimeter. That would be our pressure. But I would actually, if you had no calculator, you could leave it just like that. All right, take a minute, write that down, think about what it was, and we'll go on to our last example. Yippee, go Bearcats. All right, this last example is over joint variation. This may sound a little silly, but I always think about it's like more things join in the problem. They all join in together, so there's a bigger party going on. All right, so in this case, you have Z varies jointly as You could say x and y. You have z is jointly proportional to x and y. We're missing that little statement. X has x and y. Sorry. And so then the little formula is z equals k, y, x, y. Don't get confused by the difference in the variables. Please don't. Z would be the beginning one, just like it was like the y before. I'm not really wild that they write it that way. I would probably prefer saying y equals k, x, z, but that's how they do that. So, but these are just two things that it is jointly proportional. But jointly is going to be the same as direct variation in terms of being multiplied by the constant. So this time the simple interest, our interest will be our z. So we're going to write a little equation. I equals, for a certain savings account is jointly proportional, and we know we're going to have that k in there. It's proportional to the time and the principal. So the time and the principal. The time and the principal. All right. After 1 quarter are 3 months. Well, 3 months is 1/4 of a year, and you want to base everything, or 0.25 of a year. You want to base everything on annual, on a yearly rate. The interest on a principal of $5,000 is $43.75. So let's plug in. So we know the interest is $5,000. I'm sorry, the principal amount is $5,000. The interest is $43.75. So our interest is $43.75 equals our constant. And we know that that is in 1/4 of a year. That's our time. And our principal amount was $5,000. All right, so we would go through, we would solve for k. When we do, we get approximately 0.035, which is approximately 3.5%, but we're going to use a decimal in our equation. So we would write that our interest is equal to, this is our formula, 0.035 times time multiplied by principal. Time multiplied by principal. And now if you want to find the interest rate after 3 quarters, well, 3 quarters wouldn't be 1/4, it'd be 3/4. It'd be 3/4. So your time, your interest would be 0.035 times 3/4 times the principal amount of $5,000. I want you to give me the answer to that question, and I will look for that in your notes. Hope you have a great weekend. I'll see you on Monday, and go Bearcats!